You are already touching it. Right now, this exact moment, the mattress beneath you, the floor beneath that, the foundation beneath that, going down layer after layer. Rock, and below the rock, more rock, and below that, heat, and below the heat, liquid iron spinning at the rate that creates the magnetic field, keeping the sun's charged particles from stripping away the atmosphere you are breathing. You are lying on a living planet, not living the way a cat is living, or the way a tree is living in its own way, with its own metabolism, its own circulation, its own temperature regulation, its own respiration. The earth breathes in and out every season the forests of the northern hemisphere, absorbing carbon dioxide in spring and summer, releasing it in autumn and winter. If you could watch the earth's atmosphere from space over a year, you would see it pulse, like breathing, the planet breathing, and you are lying on it. You are part of it. Your atoms, every single one came from it. We're processed by it. We'll return to it. You are not on the earth. You are a temporary expression of the earth wearing the shape of you for a while. Tonight I want to tell you about this planet, not the dry textbook version, not the Wikipedia summary. I want to tell you what the earth actually is, what it does, how old it is, what it has survived, what it contains, what it is doing right now, as you breathe, as the room settles, as the night does what the night does. 100 things about this extraordinary world. Some will surprise you. Some will make you feel very small. Some will make you feel connected to something much larger than yourself. And I hope that by the end, you feel what I feel when I think about this planet. Not anxiety, not guilt, something closer to awe and something closer to love. So close your eyes, feel the planet beneath you. It has been holding things for 4.54 billion years. Tonight, it's holding you. Let it, the living machine, the mechanics of a planet. The Earth is 4.54 billion years old, 4.5 billion years. I want you to try to feel that number, not understand it, feel it. If the entire history of the Earth were compressed into a single calendar year, complex life would first appear in late November. Dinosaurs would appear on December 26th. The first modern humans would appear at 11:48 p.m. on December 31st. All of recorded human history, every civilization, every empire, every invention, every word ever written would fit into the last 11 seconds before midnight. 11 seconds. Out of a year, we extraordinarily new here. The Earth was ancient before the first human eye ever looked at it, and it will be ancient long after the last one closes. The Earth has a heartbeat, not a metaphor, a real electromagnetic pulse, called the Schumann resonances. The space between the Earth's surface and the ionosphere acts like a resonant cavity. Lightning strikes happening approximately 100 times per second around the world excite electromagnetic waves in this cavity. The fundamental frequency, approximately 7.83 Hertz, roughly 8 pulses per second. The Earth vibrates at 8 pulses per second, continuously every second of every day since there has been an atmosphere and lightning for billions of years. The planet has a heartbeat, and it has been beating longer than anything alive on its surface. The Earth hums, separate from the Schumann resonances, a different vibration. Geologists discovered in the 1990s that the Earth is always vibrating at frequencies between about 2 and 7 millihertz, far too low to hear, lower than the lowest note on any musical instrument. This hum, the Earth's free oscillations, is produced by the interaction of ocean waves with the seafloor. The ocean presses on the seafloor rhythmically with the waves, and the planet rings like a struck bell, very slowly, very quietly. The planet is always ringing. You cannot hear it, but it is there. The Earth is not a sphere. You knew this, perhaps, but the specifics are surprising. The Earth bulges at the equator. The equatorial radius, the distance from the center to the equator, is about 21 kilometers greater than the polar radius. So the Earth is slightly flattened at the poles and slightly bulging at the equator, like a ball pressed between two hands. This bulge is caused by the Earth's rotation. The centrifugal effect of spinning at over 1,600 kilometers per hour at the equator, which means the summit of Mount Chimborazo in Ecuador, close to the equator on the bulging side, is actually the point farthest from the Earth's center, not Everest. Everest is the highest mountain above sea level. Chimborazo is the farthest from the center. The same mountain, different measures, different answers. The world is not as simple as it looks. The Earth is slowing down. Every year, the day gets slightly longer, by about 1.7 milliseconds per century. Not much, but over geological time, it adds up. 4 billion years ago, a day on Earth was only about 6 hours long. The Earth was spinning much faster, and it is slowing because of the moon. The moon's gravity creates tidal bulges in the Earth's oceans. Those bulges exert a gravitational drag on the spinning Earth. Very slowly, the Earth's rotation decelerates. The moon steals a tiny amount of the Earth's rotational energy and uses it to move further away from us. The moon is receding at about 3.8 centimeters per year. The moon is leaving us imperceptibly, unavoidably. The inside of the Earth is almost as hot as the surface of the Sunday. The temperature at the inner core, the solid iron ball at the center of the planet, is estimated to be approximately 5,100 to 5,400 degrees Celsius. The surface of the Sun is approximately 5,500 degrees Celsius. The center of the Earth is almost as hot as the surface of the nearest star. This heat comes from two sources: the residual heat from the planet's formation from the violent collisions that built it still slowly leaking out, and the ongoing decay of radioactive elements, uranium, thorium, potassium, 40. These elements have been generating heat inside the Earth since the planet formed, and will continue for billions of years. The Earth carries a nuclear reactor inside it. It has been running for 4.5 billion years. The deepest hole ever drilled barely scratched the surface. The Kola super deep borehole in Russia, drilled over 24 years from 1970 to 1994, reaching a depth of 12.2 kilometers. That sounds deep until you remember the center of the Earth is 6,371 kilometers away. We drilled 12 kilometers. We reached 0.19% of the way to the center. At 12 kilometers depth, the temperature was already 180 degrees Celsius. Too hot for the drill bits to function. The project was abandoned. The interior of our own planet remains more mysterious than the surface of Mars, more mysterious than the far side of the moon. We know more about many things billions of light years away than we know about what is 100 kilometers beneath our feet. The Earth's crust is thinner than you think. The continental crust, the rock beneath the land, averages about 35 kilometers thick. The oceanic crust, the rock beneath the oceans, is only 5 to 10 kilometers thick. The Earth's radius is 6,371 kilometers. The crust is roughly 0.5% of that. If the Earth were the size of a basketball, the crust would be thinner than a sheet of paper. Everything we have ever built, every mountain we have ever climbed, every civilization that has ever existed, on a sheet of paper, floating on liquid rock. The tectonic plates are moving right now. As you read this, as you breathe, the floor beneath you is moving at the speed of fingernail growth, a few centimeters per year. The North American plate is drifting westward. The African plate is inching northward, slowly closing the Mediterranean. India is still colliding with Asia. The collision that built the Himalayas continues. The Atlantic Ocean is getting wider. The Pacific Ocean is getting smaller. In 250 million years, the continents may come together again, a new supercontinent called Pangaea, Proxima, or Amasya, depending on the model. The current arrangement of continents is temporary. Everything is temporary on geological timescales. The Earth has 5 layers, not 4. We were taught crust, mantle, outer core, inner core. But recent seismological research suggests the inner core has its own inner core, an innermost inner core with different seismic properties, perhaps a different crystal structure. A ball within a ball within a ball. The innermost inner core may be a relic of an earlier phase in the Earth's history, when the conditions in the deep Earth were different, a geological memory preserved at the center of the planet, where no instrument will ever reach. And we infer its existence from the way earthquake waves echo through it, like detecting a lump in the dark by the way sound bounces around it. The Earth has secrets at its center, and we read them through vibrations. Water everywhere, the blue planet's most extraordinary substance. The Earth has more water than you can imagine. 1.386 billion cubic kilometers of water. If you could take all the water on Earth and form it into a sphere, it would be about 1,385 kilometers in diameter. Smaller than the moon, but enormous by any human standard. The Pacific Ocean alone contains more water than the total land area of the Earth. If you could drain all the oceans and fill the Grand Canyon with that water, you would need to fill it 17 billion times. Water is the defining substance of this planet. The reason it looks blue from space, the reason life exists at all. And yet most of it is inaccessible. Most of it is the deep, dark, crushing ocean. Most of the rest is frozen in ice sheets. Only a tiny fraction, less than 1% of all the water on Earth, is the fresh water we drink and cook and grow our food with. The most valuable substance on the planet, and the most taken for granted. The water you drink is ancient. The water in your body right now has a history, a long one. The hydrogen in water, H2O, was created in the Big Bang 13.8 billion years ago. It has been part of the universe for all but a fraction of its existence. That particular water molecule in your cell, that specific arrangement of 1 oxygen and 2 hydrogen atoms, has been rain, has been glacier, has been river, has been ocean, has been in the cloud, has been absorbed by a root, has been drunk by an animal that lived and died millions of years ago, has been locked in ice for 100,000 years, has been released by warming, has been rain again, and now it is you, temporarily, before moving on. The water cycle is not just a diagram in a textbook. It is a 4 billion year story, and you are currently a chapter of it. The ocean is almost entirely unexplored. We have mapped about 20% of the ocean floor in any detail. 80% remains unmapped at high resolution. The deep ocean below 200 meters covers about 65% of the Earth's surface. It is the largest habitat on the planet, and it is almost entirely unknown. When we send submarines into the deep ocean, we find new species almost every time. New fish, new crustaceans, new worms, new microbes. In 2020, researchers found a siphonophore in an Australian canyon, a colonial organism related to jellyfish that measured 150 meters in length. 150 meters. The longest animal ever recorded. Living in an ocean we claim to understand. Found by accident because we went there for the first time. The deep ocean is a library we haven't opened, full of species we haven't named, full of processes we haven't measured, full of stories we haven't heard. The ocean makes most of the oxygen you breathe. When people think about oxygen, they think about forests. The Amazon producing oxygen, trees breathing, but most of the oxygen in Earth's atmosphere comes from the ocean, specifically from phytoplankton, microscopic, single-celled algae drifting in the sunlit upper ocean. They photosynthesize, they consume carbon dioxide, they produce oxygen. Approximately 50 to 80% of all the oxygen in the Earth's atmosphere, produced by creatures too small to see. In an ocean we largely ignore. If phytoplankton were to collapse, if ocean warming and acidification pushed them past the tipping point, the air would change. Every breath you take is partly a gift from organisms you have never seen, drifting in water you will never touch. The ocean is getting louder, not from storms, from humans, commercial shipping, sonar, underwater construction, oil and gas exploration. The ocean has become significantly noisier in the last 50 years. And this matters because the ocean is a communication medium. Whale songs travel for thousands of kilometers through the deep sound channel. Individual whales communicate across entire ocean basins, or they did. Now the noise often drowns them out. We have filled their communication medium with noise. We have made it harder for them to find each other, to navigate, to find food, to reproduce. The ocean's soundscape has changed, and most of us have never noticed because we cannot hear what we have taken. There are rivers in the ocean, not metaphorically, literally, dense, cold, salty water, denser than the surrounding ocean, flows along the seafloor in concentrated streams, called submarine rivers or density currents. Some of them are enormous. The Congo River's submarine canyon, a continuation of the Congo River, far out onto the continental shelf, and slope carries dense freshwater sediment along the seafloor, carving a channel, a river underwater, flowing into the deep ocean. The Amazon's freshwater plume extends hundreds of kilometers into the Atlantic. The ocean is not a uniform body of water. It is layered, streaked, full of distinct water masses, full of flows, full of structure that we are only beginning to understand. The deepest point in the ocean has never been fully explored. The Challenger Deep in the Mariana Trench in the Western Pacific, 10,935 meters below the surface, deeper than Mount Everest is tall. It has been visited fewer times than the surface of the moon. The first visit was in 1960. Don Walsh and Jacques Picard and the Trieste bathyscaphe. They spent 20 minutes at the bottom. They could see almost nothing through the small porthole. They stirred up sediment by the disturbance of their descent. But they got there, and what they found, the sediment, the life, the shrimp-like amphipods. The single flatfish Walsh tells us that life exists even at the absolute bottom of the world. In total darkness, under pressure more than 1,000 times the surface pressure. In near freezing water, something is there, living its life at the bottom of everything. The ocean contains mountains taller than Everest. The Mauna Kea volcano in Hawaii, measured from its base on the ocean floor to its summit, is over 10,000 meters tall. Taller than Everest be more than a kilometer, but most of it is underwater. The mid-ocean ridge, the underwater mountain chain running through all the world's oceans, is the longest mountain chain on Earth, over 65,000 kilometers long, mostly hidden beneath the sea. The tallest mountains on Earth are not where we think they are. The most dramatic landscape on Earth is not the Himalayas. It is the ocean floor, where mountain ranges stretch for 65,000 kilometers, where trenches plunge to depths that dwarf any canyon, where volcanoes build entire islands. In the dark, unseen, unmeasured, extraordinary, the ocean is slightly compressed by the weight of the water above it. At the bottom of the Mariana Trench, the pressure is about 1,086 times the pressure at the surface. This pressure compresses the water. The density of water at the bottom of the trench is about 5% higher than at the surface. The water is squeezed. The molecules are slightly closer together. If you could somehow remove all the water in the ocean but keep the density the same, the ocean floor would be measurably closer to the surface. The weight of the ocean compresses the ocean, and the pressure of the water slightly compresses the rock of the seafloor. The Earth gives slightly under the weight of its own water, a planet flexible enough to be deformed by the liquid on its surface. Sound travels differently in different parts of the ocean. In the deep sound channel, a layer of water at about 1,000 meters depth, the speed of sound is at its minimum. This acts like a lens. Sound waves traveling at that depth bend back toward the channel. They are trapped. They can travel for thousands of kilometers without spreading out, without losing much energy. This is called SOFA, soon fixing and ranging. It was discovered in the 1940s, initially used for military purposes, and then scientists realized that whales had been using it for millions of years. Whales communicate through the SOFA channel, a network of long-distance communication that predates human civilization. By millions of years, the ocean has always been a communications medium. We just discovered it recently. The whales have always known the breath of the world, the atmosphere that keeps everything alive. The atmosphere is extraordinarily thin. If the Earth were the size of a basketball, the atmosphere would be thinner than a plastic bag stretched over the ball. The troposphere, the lowest layer, where weather happens, where all life breathes, extends from the surface to about 12 kilometers. At 12 kilometers, the air is too thin to breathe without supplemental oxygen. Commercial aircraft fly at about 10 to 12 kilometers. Above the weather, in air, thin enough that you would lose consciousness without a pressurized cabin. All of life, all of weather, all of the atmospheric chemistry that keeps the planet habitable. In a layer 12 kilometers thick, on a planet 12,724 kilometers in diameter. 0.1% of the diameter. Our film, a whisper between life and the void. The sky is blue because of life, not entirely, but significantly. The oxygen in the atmosphere, the oxygen that scatters blue light and makes the sky blue, was produced by living things, specifically by cyanobacteria, beginning about 2.7 billion years ago. Before life produced oxygen, the atmosphere had very little of it. The sky may have been a different color, perhaps orange-red, from the methane and other gases of the early atmosphere. The blue sky is a product of biology. The blue you see when you look up is the result of 2.7 billion years of photosynthesis, of cyanobacteria breathing oxygen into an atmosphere that didn't have it, of life changing the planet. Until the planet looked like this, until the sky was this color. The sky is blue because of life. The atmosphere has weight. You cannot feel it. But the atmosphere presses down on every square centimeter of the Earth's surface with a force equivalent to about 1 kilogram per square centimeter. On your shoulders right now, the area of the cross-section of your body seen from above the atmosphere is pressing down with thousands of kilograms of force. You don't feel it because your body is designed to withstand it, because you evolved inside this atmosphere. Your cells are pressurized. Your blood vessels are pressurized. Your entire body is a pressure vessel, calibrated to this specific atmospheric pressure. This specific planetary surface, take that pressure away in space and body fluids would vaporize. Blood would boil. The atmosphere is not just the air you breathe. It is the pressure that keeps you intact. Lightning is hotter than the surface of the Sunday. A bolt of lightning heats the air around it to approximately 30,000 degrees Celsius, about 5 times the temperature of the sun's surface. In a fraction of a second, the superheated air expands explosively. That expansion is the thunder. The light of the lightning is the channel of superheated plasma, ionized air, glowing, and it is gone in milliseconds. But the temperature it reaches in the thin air above a summer field, above a city, above the ocean, 5 times the temperature of the sun for a millisecond, 100 times per second. Around the world, the ozone layer is recovering. In the 1970s and 1980s, scientists discovered a hole in the ozone layer over Antarctica, caused by chlorofluorocarbons, CFCs in refrigerants and aerosol sprays. The ozone layer protects life from ultraviolet radiation. Without it, the UV reaching the surface would dramatically increase the rate of skin cancer, cataracts, and damage to marine phytoplankton. In 1987, the Montreal Protocol was signed, an international agreement to phase out CFCs. Almost every nation on Earth signed it. And it worked. The ozone hole is healing. Slowly, expected to be fully restored by the 2060s, the Montreal Protocol is the most successful international environmental agreement in history. A global problem, a global solution. It worked. When people say we can't solve environmental problems collectively, I think about the ozone layer, and I find it harder to agree. The atmosphere has layers with different properties. The troposphere, weather, clouds, breathing air. The stratosphere, where jet aircraft fly, where the ozone layer lives. The mesosphere, where meteors burn up, where the air glows at night. The thermosphere, where auroras occur, where the International Space Station orbits. The exosphere, the outermost layer, where the atmosphere gradually fades into space. No sharp boundary, just a gradual thinning until there's no more atmosphere, just space. The layers are not separate. They blend, they interact. The weather in the troposphere affects the stratosphere. The solar activity affects the thermosphere, which affects everything below. The atmosphere is a single connected system, from the ground to space, full of circulation, full of chemistry, full of processes we are still learning to understand. Clouds can weigh 500,000 tons. A typical cumulus cloud, the fluffy white kind, contains about 500 million grams of water, 500 metric tons, the weight of a small skyscraper, floating because the water is dispersed as tiny droplets, each one too small and too light to fall. Held aloft by the upward movement of air, a cloud is not lighter than air. It is held up by air. There is a difference. And when the droplets combine and grow heavy enough, gravity wins, and the cloud falls. As rain, a 500,000-ton object releasing its contents softly over a landscape, a thunderstorm can release billions of tons of water. Gently or not gently, the sky is holding an extraordinary amount of water. Right now, above wherever you are, wind is one of the most powerful forces on Earth. Not a storm, regular wind. The global atmospheric circulation, the Hadley cells, the Coriolis effect, the jet streams, the system that moves heat from the equator to the poles, that distributes moisture around the planet, that drives the surface currents of the ocean. The wind is not just weather. It is the Earth's climate regulation system, moving heat, distributing water, shaping ecosystems. The rain that falls in a forest in South America may have been water that evaporated from the Pacific Ocean, carried inland by wind, condensed in clouds over the Andes, fallen as rain in the Amazon. Water cycling through the atmosphere, powered by the sun, shaped by the Earth's rotation. The wind connects everything. The atmosphere was made by volcanoes. Early in Earth's history, there was no atmosphere at all. Then volcanoes began outgassing, releasing water vapor, carbon dioxide, nitrogen, sulfur dioxide, the gases from the interior of the Earth, building the first atmosphere, a very different atmosphere from today's. Mostly carbon dioxide, no oxygen, thick, hot, a greenhouse atmosphere. The water condensed and fell as rain, filling the first oceans, and then life appeared and began to change the atmosphere. The atmosphere we breathe today is largely the product of life, of photosynthesis, of billions of years of biological transformation over volcanic outgassing. We breathe an atmosphere that life made. We live in a world that life built. Every breath you take contains atoms breathed by Julius Caesar, famously calculated by physicist Richard Feynman and others. Every breath contains approximately 1022 molecules of air. The air is well mixed. Over the Earth, over time, Julius Caesar's last breath, approximately 25 sextillion molecules, has by now spread uniformly through the atmosphere. The probability that any single breath you take contains at least one molecule from Caesar's last breath, essentially certain. Not just Caesar. Every person who ever lived, every animal that ever breathed, every leaf that ever photosynthesized. The air is a shared medium, a commons, a library of exhalations. Going back to the first breath of the first breathing creature, you are breathing history, the green world, life, forests, and the web of living things. There are more trees on Earth than stars in the Milky Way. An estimated 3 trillion trees. Sanjiao, the Milky Way contains between 100 and 400 billion stars. There are 7 to 30 times more trees on Earth than stars in our galaxy. The first time I read that statistic, I had to stop, because somehow the number of trees is more astonishing than the number of stars. Because the trees are here, within reach, because I have touched a tree and never touched a star. The number of trees on the planet is a number that changes how I see the world. Every ordinary street tree is part of 3 trillion. Every sapling is part of the largest living structure in the solar system. Trees communicate through underground fungal networks. The Wood Wide Web, a network of mycorrhizal fungi connecting the roots of trees. Trees use this network to exchange nutrients, carbon, water, chemical signals, warning signals. When a tree is attacked by insects, it releases chemical signals through the network. Neighboring trees pick up the signals and begin producing defensive chemicals, preparing for an attack that hasn't reached them. Parent trees send excess carbon to their seedlings through the network. Seedlings growing in shade, unable to photosynthesize enough, are subsidized by their parents. The forest is not a collection of individuals competing for resources. It is a community with communication, with resource sharing, with something that at least functionally resembles care. The largest living organism on Earth is a fungus. Armillaria ostoya, a honey fungus in the Malheur National Forest in eastern Oregon, covers approximately 9.65 square kilometers, an area larger than 1,300 football fields, estimated to be between 2,400 and 8,650 years old. Most of it is underground. A network of fungal threads, mycelium spreading through the soil. What you see above ground, the mushrooms are just the fruiting bodies. The visible tips of something enormous, the largest living thing on Earth, is invisible, hidden underground, ancien, spreading quietly, without anyone noticing, for thousands of years. There are places on Earth where trees produce their own weather. The Amazon rainforest. The trees transpire so much water, releasing it through their leaves as water vapor, that they create their own atmospheric rivers. Great columns of moisture rising from the forest, traveling inland on the wind, condensing, falling as rain, hundreds of kilometers from the coast. The Amazon doesn't just grow in a wet climate. It creates its own wet climate. The trees make the rain makes the trees. A self-sustaining loop, a forest ecosystem so large that it has its own weather. If the Amazon is sufficiently deforested, this loop could break. The moisture could stop cycling. The interior could dry out. The remaining forest could die, a tipping point, after which the largest forest on Earth converts to savanna permanently. The trees are not just passengers in the Amazon, they are the drivers. The soil is alive. Every teaspoon of healthy soil contains more living organisms than there are people on Earth. Bacteria, fungi, protozoa, nematodes, mites, springtails, an entire ecosystem, invisible, in a pinch of dirt. The soil is alive from top to bottom. Bacteria break down organic matter. Fungi connect roots. Earthworms aerate and mix the layers. Insects tunnel and redistribute nutrients. Microarthropods feed on fungi and bacteria. The whole system cycling nutrients, making minerals available to plants, maintaining the structure of the soil. The soil is not dirt. It is a community, a biome, one of the richest habitats on the planet. And we stand on it every day without thinking about it. Life exists in places that should be impossible. Hydrothermal vents on the ocean floor, where superheated water at 400 degrees Celsius erupts from the seafloor, where the pressure would crush a person, where there is no sunlight. Life, tube worms, 2 meters long, giant clams, shrimp, crabs, an entire ecosystem based not on photosynthesis but on chemosynthesis, using the chemicals in the vent water as an energy source. Life not powered by the sun, powered by the heat of the Earth's interior. And life in Antarctic ice, life inside rocks, life in highly acidic volcanic springs, life in hypersaline lakes, life in the upper atmosphere, life at the bottom of the deepest ocean trench. The range of environments in which life can exist is greater than anyone imagined, much greater, and it suggests that life, once it arises, is extraordinarily difficult to eliminate. The oldest known living things are in the ocean, not the bristlecone pines in California, not the great baobabs of Africa. In the ocean, deep ocean sediments, in sediments 100 meters below the seafloor of the South Pacific Gyre, one of the most nutrient-poor parts of the ocean, scientists found microbes living in sediments 100 million years old. The microbes had been dormant or growing at unimaginably slow rates for 100 million years. 100 million years. Since before the extinction of the dinosaurs. And when scientists brought them to the surface and gave them nutrients, they woke up. They started reproducing 100 million years of patience. And they were still alive, still capable of waking up, still capable of reproducing. Coral reefs are the cities of the sea. Coral reefs cover less than 1% of the ocean floor, but they support over 25% of all marine species, more biodiversity per unit area than almost any other habitat on Earth. The density of life, the layering, the interdependence. Coral reefs are called the rainforests of the sea, but in some ways they exceed even that comparison. The coral itself is an animal, a tiny animal called a polyp that builds a calcium carbonate skeleton and lives in a symbiotic relationship with algae called zooxanthellae. The algae live inside the coral cells. They photosynthesize. They provide the coral with up to 90% of its energy. In return, the coral provides the algae with shelter and nutrients, a partnership, ancien, the basis of everything. When the water warms, the coral expels the algae. The coral bleaches, white, stressed, and if the warmth persists, dead. The reef dies, and with it, everything that depended on it. The Amazon River contains 20% of all fresh water flowing into the world's oceans. One river, 1/5 of all the fresh water entering the sea. The Amazon discharges approximately 209,000 cubic meters of water per second. The second largest river in the world, the Congo, discharges about 41,000 cubic meters per second. The Amazon is 5 times larger. The plume of fresh water, where the Amazon meets the Atlantic, extends hundreds of kilometers out to sea. The ocean off the coast of Brazil is measurably fresher than anywhere else. Sailors in the 16th century reported finding fresh water in the middle of the ocean, far from the sight of land. Puzzled, confused, until they understood they were floating over the Amazon's outflow, a river so large it freshens the ocean. The number of insects on Earth is staggering, approximately 10 quintillion. Each sensing, if you divided all insects equally among all humans, each person would receive approximately 1.4 billion insects. Insects pollinate the plants that feed us. Insects decompose dead material, cycling nutrients. Insects are food for birds, fish, and mammals. They are the foundation of most terrestrial food chains, and they are declining. By some estimates, Insect populations have declined by 25 to 45% in the last 30 years. In some regions, flying insect biomass has declined by over 75%. We are losing the foundation quietly without most people noticing because we don't see insects the way we see birds or mammals because they are small and numerous and seem impossible to count or mourn the deep past what fossils tell us. The fossil record is a tiny fraction of what lived. For an organism to become a fossil, specific conditions must be met. It must die in a place where it will be quickly covered by sediment. It must not be eaten or decomposed before burial. The sediment must become rock. The rock must survive over millions of years. The rock must eventually be exposed at the surface. And then someone must find it. The chance of any individual organism becoming a fossil is extraordinarily small. Perhaps 1 in a billion, perhaps less. The fossil record represents a vanishingly small fraction of the diversity of life that has existed on Earth. Entire lineages have lived and died without leaving a trace. What we know about the history of life is a glimpse, a few pages, from a book of incalculable length. Life existed for over 3 billion years before animals. Complex multicellular animal life with eyes and legs and nervous systems first appeared about 540 million years ago. The Earth is 4.54 billion years old. For the first 4 billion years, life was mostly microbial, single cells, or simple multicellular mats, bacteria and archaea, not boring, extraordinary, changing the atmosphere, building the first reefs, creating the conditions for the later explosion of animal life, but invisible to the naked eye, without form as we understand form. The story of life on Earth is mostly the story of the invisible, of bacteria, of microbes, of the things that built the world for the things that came after. The Great Dying was the worst event in the history of life. 252 million years ago, the Permian-Triassic mass extinction killed over 90% of all marine species and over 70% of all terrestrial vertebrate species, the worst extinction event in the last 500 million years, perhaps the worst in the entire history of complex life, caused by catastrophic volcanic eruptions in what is now Siberia. The Siberian Traps, one of the largest volcanic events in Earth's history, erupting for perhaps 2 million years, releasing carbon dioxide and sulfur dioxide on a scale that poisoned the atmosphere and acidified the oceans. The oceans became anoxic, depleted of oxygen, dead zones, spreading until almost everything was gone. The recovery took 10 million years. The world that emerged was almost unrecognizable. And from the survivors of that catastrophe came the dinosaurs. And eventually us. Every catastrophe makes space for what comes next. Birds are dinosaurs, not descended from dinosaurs, not related to dinosaurs. They are dinosaurs, avian dinosaurs, a lineage that evolved feathers and flight during the Jurassic period and survived the mass extinction 66 million years ago. When you watch a sparrow hop across the sidewalk, you are watching a dinosaur. When you eat chicken for dinner, you are eating a dinosaur. The dinosaurs did not go extinct. They are outside your window, singing every morning. The Cambrian explosion was the most creative moment in the history of animal life, 541 million years ago. In a period of perhaps 20 to 25 million years geologically brief, almost all the major body plans of animals alive today appeared in the fossil record for the first time. Eyes, shells, legs, predation, defense, the arms race of ecology. Before the Cambrian, mostly soft-bodied, simple organisms. After it, a world of complexity. The explosion was not perfectly understood. Several factors probably contributed: rising oxygen levels, the end of snowball Earth, the evolution of predation creating pressure for defense, genetic innovations allowing new body plans. But the precise trigger, what caused the explosion to happen when it did, after billions of years of relative stasis, is still debated. The Cambrian explosion is the most dramatic event in the history of animal life, and it is not fully explained. The asteroid that killed the dinosaurs left a layer of iridium around the world. When the asteroid, roughly 10 to 15 kilometers in diameter, struck the Gulf of Mexico 66 million years ago, it vaporized rock. That rock mixed with the debris thrown into the atmosphere. And over the following months and years, it settled everywhere on Earth. A thin layer of clay, rich in iridium, an element rare on Earth but common in asteroids. This layer, the KPG boundary, can be found in rocks all over the world, in limestone, in chalk, in shale, a thin dark line marking the end of one world and the beginning of another. Geologists can recognize it everywhere they find it. A fingerprint of catastrophe, laid down in a single geological moment. The evidence for the asteroid impact, literally written in stone. The Earth has been through 5 confirmed mass extinctions, and possibly a 6th is on the way. The Ordovician Silurian extinction, 443 million years ago, possibly triggered by a gamma-ray burst from a nearby star. The late Devonian extinction, 375 million years ago. The cause still debated. The Permian-Triassic extinction, 252 million years ago, the worst. The Triassic-Jurassic extinction, 201 million years ago, linked to massive volcanic activity. The Cretaceous-Paleogene extinction, 66 million years ago. The asteroid, 5 times. The diversity of life was dramatically reduced. 5 times the survivors rebuilt. The Earth is resilient, not in a comforting way, in a profound way. Life, once established, is almost impossible to extinguish. But the particular forms of life, the species, are fragile, dependent on specific conditions, replaceable, but not recoverable. Extinction is permanent. Some of the Earth's oldest rocks contain evidence of early life. The Isua Greenstone Belt in Greenland, 3.7 billion years old, the oldest known sedimentary rocks on Earth, and within them, evidence of biological activity. Graphite with the isotopic signature of life. Carbon that has been processed by living organisms. Evidence of stromatolites, mats of microbial life at 3.7 billion years. Life appeared so quickly after the Earth's surface cooled that some scientists argue life is an almost inevitable consequence of the right conditions. Not a lucky accident, but a predictable outcome of chemistry. Given enough time and water and energy, the universe may be full of life. Or we may be uniquely lucky. The debate continues. Humans share more DNA with mushrooms than with plants. Surprising, but true. Fungi, the kingdom that includes mushrooms, yeasts, and molds, diverged from animals about 1 billion years ago. Plants diverged from the line leading to both fungi and animals much earlier. So fungi and animals share more recent common ancestry than fungi and plants. Fungi breathe oxygen and exhale carbon dioxide. Fungi have cell walls made of chitin, the same material as insect exoskeletons. Fungi digest food externally, secreting enzymes and absorbing the products. They are strange, ancient, and more closely related to you than to the apple tree. The family tree of life is not organized the way we intuitively expect. The Amazon was a sea 15 million years ago, when the Andes were still growing, before the mountains were high enough to block the flow of water to the Pacific. The Amazon basin, the largest river drainage in the world, was not a river. It was an inland sea, a vast, shallow sea connected to the Caribbean, full of marine life. The ancestors of today's pink river dolphins, which live in the Amazon, were marine dolphins, trapped in the fresh water when the sea became a river, evolving into the extraordinary freshwater dolphins we see today, pink, long-snouted, swimming in the Amazon, the descendants of ocean creatures stranded by geology, the forces beneath, volcanoes, earthquakes, and the moving earth. The earth experiences approximately 500,000 earthquakes per year. Only about 100,000 are strong enough to be felt. Only about 100 are strong enough to cause damage. But the planet is always moving. Seismographs somewhere in the world are always recording, always picking up vibrations. Some from distant earthquakes, some from ocean waves, some from the Earth's own free oscillations. The planet never rests, never stops moving. The ground beneath your floor is shifting, very slightly, right now, as it has for 4.5 billion years. The largest earthquake ever recorded had a magnitude of 9.5. The 1960 Valdivia earthquake in Chile, the most powerful earthquake in recorded history. It ruptured a fault zone 1,000 kilometers long. It generated a tsunami that struck the coast of Chile within 15 minutes. That crossed the Pacific Ocean and struck Hawaii, Japan, and the Philippines, killing people thousands of kilometers away. The earthquake was so powerful that it set the entire Earth oscillating like a struck bell. For days, for weeks, seismographs around the world detected the Earth's free oscillations, frequencies of the planet vibrating at its own natural frequencies. The ground beneath every person on Earth was moving because of one earthquake. In Chile, volcanoes are responsible for much of the Earth's surface. The Hawaiian Islands, the Canary Islands, Iceland, the Galapagos Islands, New Zealand, all volcanic, built from the ocean floor by magma. Hawaii is the result of a hotspot, a plume of extremely hot mantle material rising from deep within the Earth, punching through the Pacific plate, creating a chain of volcanic islands as the plate moves northwestward over the hotspot. The big island of Hawaii is the youngest, still being built. Lava flowing, new land being added. You can watch it happen. The Earth making itself. In real time, the largest volcanic eruption in human history is not Pompeii. Most people think of Pompeii or Krakatoa, but the largest volcanic eruption in recorded human history was the 1815 eruption of Mount Tambora in Indonesia. It ejected approximately 160 cubic kilometers of material into the atmosphere. Krakatoa ejected about 25. Tambora ejected more than 6 times as much. The eruption killed at least 71,000 people directly, but the indirect effects were greater. The ash and sulfur dioxide injected into the stratosphere reflected sunlight, cooling the planet. 1816 became known as the year without a summer. In New England, there was frost in June. Crops failed across Europe and North America. Famine followed. Cholera outbreaks followed the famine. The total death toll from Tambor's effects may have been over 100,000. One volcano, changing the global climate. For years, the Ring of Fire contains 75% of the world's volcanoes. The belt of seismic and volcanic activity surrounding the Pacific Ocean, from New Zealand through Asia to Alaska to South America, 452 volcanoes, where tectonic plates collide and subduct, where oceanic crust dives beneath continental crust, melts, freezes at magma, and erupts. The Ring of Fire is the most geologically active region on Earth, the most dangerous, the most dynamic, and it sits around the edges of the largest ocean in the world, framing the Pacific. A ring of fire around a ring of water on a planet that has always been in motion. The Mid-Atlantic Ridge is creating new ocean floor every day. At the boundary between the North American and Eurasian plates, and between the South American and African plates, magma rises from the mantle, fills the gap, solidifies, becomes new oceanic crust. At a rate of about 2.5 centimeters per year, the Atlantic Ocean is widening by 2.5 centimeters per year. In 50 million years, the Atlantic will be roughly 1,250 kilometers wider than today. The North American plate drifting west, Europe drifting east, the ocean floor spreading, new rock being born from the mantle. Every day, at the bottom of the Atlantic, the Yellowstone supervolcano last erupted 640,000 years ago. Yellowstone National Park sits atop one of the largest volcanic systems on Earth, a supervolcano capable of eruptions far larger than any in recorded history. The last supervolcano eruption at Yellowstone ejected about 1,000 cubic kilometers of material, more than 600 times the Tambora eruption. If a similar eruption happened today, it would bury much of the central United States in ash, cool the global climate for years, devastate agriculture worldwide, and it will erupt again. We don't know when. The Yellowstone system erupts roughly every 600,000 to 700,000 years. The last eruption was 640,000 years ago. The math is unsettling, but the timing of volcanic systems is not clockwork. It could be 10,000 years from now, or 800 or tomorrow. We monitor the system carefully. The ground rises and falls above the magma chamber. The hydrothermal activity, the geysers, the hot springs reflects the activity beneath. Yellowstone is watched carefully by people who know what it contains. Iceland is the visible part of the Mid-Atlantic Ridge. Iceland sits directly on the Mid-Atlantic Ridge, the place where the North American and Eurasian plates are pulling apart. The island is being torn in two, very slowly. The Rift Valley that runs through Iceland, visible in the landscape, is the surface expression of the tectonic boundary. You can stand in Iceland and put 1 foot on the North American plate, 1 foot on the Eurasian plate, standing on the boundary where two continents are pulling apart, where new land is being created, where the ocean floor is spreading, one of the most geologically extraordinary places on Earth, and one of the most beautiful, because the volcanic activity that makes it dangerous also makes it extraordinary. Hot springs, geysers, lava fields, the smell of sulfur, the aurora borealis visible in winter. Iceland is the Earth at its most naked, where the interior is close to the surface, and the surface is still being made. The Sahara Desert was once green, about 10,000 to 5,000 years ago. During the African humid period, The Sahara today, the world's largest hot desert, was savanna, with rivers and lakes, with hippopotami and crocodiles, with elephants and cattle, with people. Rock paintings in the Sahara show animals that require water: giraffes, cattle, people swimming, painted on rocks that are now in the middle of one of the driest places on Earth. What changed? The Earth's axial tilt shifted slightly, changing the pattern of monsoon rainfall. The monsoons that had been reaching the Sahara pulled back. The lakes dried. The rivers disappeared. The savanna died. The desert spread, and the people and the animals left or died. A green world, lost to a small change in the Earth's orbit, buried under sand, waiting for the next humid period, which may come again in a few thousand years. The Dead Sea is the lowest point on Earth's surface, 430 meters below sea level. On the border of Jordan and Israel, the water is almost 10 times saltier than the ocean. So salty that you float effortlessly, your body buoyed up by the density of the brine. So salty that very little lives in it. Bacteria, some archaea, but almost nothing else. The name is apt, and it is shrinking. The Jordan River, its main source of water, has been so heavily diverted for agriculture that the flow into the Dead Sea has dropped by 95%. The Dead Sea loses about a meter of depth every year. The shoreline has retreated by kilometers since the 1960s. The sinkholes forming on the receding shore are a visible sign of an ecosystem in collapse. The Dead Sea is dying, faster than its name implies. The human Earth, our species, and the planet. Modern humans have existed for about 300,000 years. The Earth is 4.54 billion years old. Our species has been here for 0.0066% of that. In the compressed calendar I mentioned at the beginning, where the Earth's history is 1 year, we appear in the last 11 seconds. And in those 11 seconds, we have learned to control fire, developed language, invented agriculture, built cities, created writing, developed mathematics, philosophy, science, art, sailed to every continent, mapped the ocean floor, sent probes to the edge of the solar system, photographed black holes, decoded the human genome, changed the composition of the atmosphere, initiated what may be the 6th mass extinction, 11 seconds, on a 4-5 billion year old planet. We are extraordinary and extraordinarily dangerous. Both things equally true. The Earth is now in the Anthropocene, a proposed geological epoch, the age of humans, the point at which human activity became the dominant force shaping the Earth's surface, atmosphere, and biosphere. The exact start date is debated. Some propose the mid-20th century, when nuclear bomb tests left a radioactive layer in sediments worldwide, a layer that can be found in ice cores, in ocean sediments, in lake beds, a global signal of human activity, unmistakable, a geological epoch defined by a species, the first time in the 4-5 billion year history of the planet that a single species became a geological force. We are the event, the boundary, the before and after. We have moved more material than any geological process. Every year, humans move approximately 57 billion tons of rock and sediment through mining, through construction, through agriculture. Every geological process combined, rivers, glaciers, wind, All erosion moves approximately 53 billion tons per year. Humans have surpassed all the rivers, all the glaciers, all the wind. Combined, we are the single most powerful force reshaping the Earth's surface, more powerful than the processes that shaped it for 4 billion years before we arrived. This is either the most remarkable thing about our species or the most concerning, probably both. There's plastic at the bottom of the Mariana Trench. A plastic bag was found there in 2018. Microplastics, tiny fragments of degraded plastic, have been found everywhere. Antarctic ice cores, Arctic snow, ocean trenches, the air above mountains, human blood, human breast milk, human placentas, the deepest, most remote places on Earth, all contaminated. Plastic is now a geological tracer, a signature of this moment in time. The way a layer of iridium marks the asteroid impact 66 million years ago. The plastic layer marks us, our era, our choices written in the sediments for future geologists to find. The ozone hole above Antarctica varies by season. It forms in the southern spring as stratospheric temperatures drop over the Antarctic winter, forming polar stratospheric clouds, on whose surfaces the chemical reactions that destroy ozone proceed. The hole grows, reaching its maximum extent in September and October. Then warming temperatures break down the polar vortex. The ozone-depleted air mixes with ozone-rich air from lower latitudes. The hole shrinks, closes, until the next Antarctic winter. The cycle, every year, and slowly, because of the Montreal Protocol, the maximum extent of the hole is getting smaller. The healing is slow. Chemicals already in the stratosphere will persist for decades, but it is happening. The ozone layer is healing, one of the most remarkable environmental recovery stories of the 20th century. A reminder that collective action can work. When the will is there, the number of trees is declining despite the extraordinary 3 trillion trees. The number is declining. About 15 billion trees are cut down per year. About 5 billion are planted. The net loss, about 10 billion trees per year. Since the agricultural revolution, humans have cut down approximately half of all the trees that existed. 3 trillion trees today, perhaps 6 trillion before farming. We have deforested half the earth. The forests of Brazil, of Southeast Asia, of Central Africa, being cleared for agriculture, for timber, for development. The forests that took millions of years to develop, cleared in years, in decades, irreplaceable, because the soil beneath them is often fragile, and the ecosystem is held together by relationships too complex to rebuild. The Earth's population of wild animals has fallen by 70% since 1970. The Living Planet Index, published by the World Wildlife Fund, based on data from thousands of species. A 70% decline in the average population size of wild mammals, fish, birds, reptiles, and amphibians. In 50 years, the equivalent of losing 7 of every 10 wild animals on the planet in a single human lifetime. This is the context for the word extinction, not just species disappearing, populations collapsing, ecosystems unraveling, a world becoming quieter, emptier, less complex, less resilient, less alive, happening right now in our lifetimes. And yet, there are stories of recovery. The humpback whale, nearly extinct by the mid-20th century. Protection in 1966. A prohibition on commercial whaling, slow recovery, painful, uncertain, and now humpback whale populations in the Southern Ocean have recovered to perhaps 80% of pre-whaling numbers. Populations that were a few thousand individuals, now in the hundreds of thousands, still endangered, still vulnerable, but recovered. The bald eagle, decimated by DDT, the pesticide accumulated in their bodies, made their eggs too thin to hatch. They nearly disappeared from the contiguous United States. DDT, protection under the Endangered Species Act, captive breeding, and recovery from fewer than 500 nesting pairs to over 9,000. The Chernobyl exclusion zone. After the nuclear disaster in 1986, humans left and nature returned. Wolves, bears, lynx, eagles, one of the most wildlife-rich areas in Europe, not because radiation is harmless, but because humans are hard on ecosystems. And in our absence, life returns. These stories matter, not as excuses for complacency, as evidence that recovery is possible, that the living world is resilient, given the chance. The Sahara Desert is greening. At the edges, a phenomenon called the Green Sahara, or the greening of the Sahel. Rainfall has increased slightly at the southern edge of the Sahara. In the Sahel region, the vegetation is expanding northward, woody plants growing in areas that were recently bare. The process is slow, partial, not uniform, but measurable, driven partly by increased CO2, which makes plants more water efficient, partly by changing rainfall patterns. The desert at its margins is slowly retreating. This does not compensate for desertification elsewhere or for the broader climate changes, but it shows that the system is not simple, that change is not always in one direction, that the earth is complex and full of surprises. The earth feeds 8 billion people. Right now, more people than at any point in history. The earth, its soil, its water, its sunlight, its chemistry supports more human life than it ever has. 1 billion people was reached around 1,800, 7 billion by 2011, 8 billion by 2022. The earth is feeding us, all of us, through agriculture that covers half its habitable land, through fisheries that exploit most of the ocean, through aquifers draining faster than they refill, through soil eroding faster than it forms. The earth is feeding us at a cost that is not evenly distributed, a cost that is being paid by the future. The question is not whether the earth can feed us, it is feeding us. The question is whether we can sustain the system that does it, the hidden things, what lives in and under the earth. Fact 71, there is more life underground than above it. The subsurface biosphere, the total mass of life in the deep subsurface, in rocks, in aquifers, in deep sediments, may equal or exceed the total mass of all life on the surface. Bacteria and archaea living in rock cracks kilometers underground, living on hydrogen produced by chemical reactions between water and rock, without sunlight, without photosynthesis, without any connection to the surface world, reproducing once every few thousand years, or slower, essentially immortal, on human timescales, living in conditions that would be lethal to almost any surface organism. The deep biosphere is one of the most remarkable discoveries of the late 20th century. Life, everywhere, even in the deep rock, even in places we thought were sterile. Even there, There are ancient lakes under the Antarctic ice sheet. Lake Vostok, the largest, beneath about 4 kilometers of ice, a liquid lake in the dark under enormous pressure, cut off from the surface for approximately 15 to 25 million years. No sunlight, no contact with the atmosphere, no input of nutrients from the surface. And yet, scientists drilling into the ice above the lake found hints of biological material. The possibility not confirmed that something lives in Lake Vostok, something that has been evolving in total isolation for millions of years in a dark, cold, pressurized lake. Under kilometers of ice in Antarctica, we have not yet sampled the lake properly. The challenge of drilling to it without contaminating it, without introducing surface organisms into a pristine environment is enormous. But somewhere beneath the ice, a lake has been waiting for millions of years. The largest cave in the world could contain a skyscraper, the San Dung Cave in Vietnam, discovered by a local farmer in 1990, not fully explored until 2009. The largest cave passage in the world by volume, approximately 9 kilometers long, up to 200 meters wide, over 150 meters tall, large enough to contain a 40-story skyscraper, with room to spare. Inside the cave, its own ecosystem, jungle growing on the floor, nourished by sunlight filtering through collapsed sections of the ceiling, its own weather, clouds forming inside the cave, its own river, an entire world, underground, hidden for millennia, undiscovered until 1990. There are rivers underground, not just in caves, in aquifers, porous rock, saturated with water. The Ogallala Aquifer, beneath the Great Plains of the United States, one of the largest aquifers in the world, containing water deposited over millions of years. During wetter periods, during ice ages, ancient water, called fossil water because it accumulated long before any human civilization, being pumped out to irrigate crops at a rate far exceeding the natural recharge. The Ogallala is being depleted. In some regions, the water table has dropped by more than 30 meters in the last 50 years. A water resource that took millions of years to accumulate, being used up in a century. Lava can travel underwater. Pillow lava. When magma erupts under the ocean floor, particularly at mid-ocean ridges, the outer surface quenches instantly in the cold water, forms a solid skin, but the inside is still molten. The lava inflates like a pillow, billowing outward, rounded, building up in stacks. Pillows, thousands of them, on the ocean floor, at mid-ocean ridges around the world. Geologists find them on land too when ancient ocean floors were uplifted by plate tectonics and became mountains. The pillow lavas of a firelights ancient seafloor now on land can be found in places like Cyprus, in Newfoundland, in Oman. You can touch rock that formed at the bottom of an ancient ocean, on top of a mountain. The earth recycles everything. The earth has minerals that form nowhere else in the solar system. Life changes rock. The minerals that form in an oxidizing atmosphere in the presence of oxygen produced by life are different from the minerals that form in a reducing atmosphere. A lifeless earth would have a different mineralogy, a different suite of rocks, of crystals, of gemstones. The diversity of Earth's minerals, over 5,000 known mineral species, is partly a product of the planet's age. Its geological activity and its life. Many of Earth's most beautiful minerals formed in the presence of oxygen. Malachite, azurite, turquoise, minerals that, as far as we know, don't form on any other planet. The beauty of the mineral kingdom is a product of life, a gift from 4 billion years of chemistry. Gold in river sediments came from ancient meteorites. Gold is rare, extraordinarily rare. The gold we mine from the crust of the earth in veins of quartz, in placer deposits in riverbeds, is there because of meteorites. When the earth first formed, it was largely molten. Gold, being dense, sank to the core, where it remains, inaccessible. The gold in the crust today arrived later, delivered by a late, heavy bombardment of asteroids. About 4 billion years ago, the gold in your jewelry, the gold in electronic circuits, the gold in every wedding ring ever worn, came from space, delivered by asteroids that fell to Earth before the first cell existed. The world's largest diamond deposit is in Russia, beneath the Popigai crater, a 100-kilometer wide impact crater in Siberia, formed about 35 million years ago. When an asteroid struck, the force of the impact compressed the graphite in the rock and created diamonds, trillions of carats of diamonds, more than the entire global supply previously known. The diamonds are of a type called impact diamonds, or Lance daylight, formed instantly by the shock wave of the impact, harder than conventional diamonds. The asteroid that created the Popigai crater also created what may be the largest diamond deposit on Earth. Disaster and treasure. From the same event, the mystery of time, how the Earth records its own history, ice cores are the Earth's diary. Scientists drill into the ice sheets of Antarctica and Greenland, extracting cylinders of ice that has been accumulating year by year for hundreds of thousands of years. Each layer contains air bubbles, trapped air from the atmosphere at the time the snow fell. Scientists analyze those air bubbles, measure the concentrations of greenhouse gases, carbon dioxide, methane, the temperature inferred from the isotopic composition of the ice, and they read the history of the climate going back 800,000 years. Every ice age, every warm period, every volcanic eruption large enough to leave a chemical signature, all of it preserved in ice, in layers, 1 year at a time. The Earth keeping its own records in a library made of frozen water. At the bottom of the world, tree rings record every drought, every cold year, every good year. Dendrochronology, the science of reading tree rings. Every year, a tree adds a new ring. Wide in good years, warm, wet, plenty of light. Narrow in bad years, cold, dry, stressed, sometimes scarred by fire, by insect attack. The rings are a record of the local climate year by year, for as long as the tree lived, by overlapping the ring patterns of living trees, ancient dead trees, and preserved timber in old buildings. Scientists have built a continuous record going back over 13,000 years, a continuous record of climate year by year for 13,000 years. The oldest building timbers in Europe, the ancient oaks from bogs, the bristlecone pines, all telling the same story of drought and abundance, of warm centuries and cold ones, of the irregular pulse of climate over millennia. Ocean sediments record millions of years of climate. The tiny shells of foraminifera, single-celled organisms sink to the ocean floor when they die and accumulate layer by layer, year by year, millennium by millennium, over millions of years, preserved in the sediment. The chemistry of their shells records the temperature of the ocean when they formed. The oxygen isotope ratio in the shells tells scientists how much ice was on the planet, how cold it was. Scientists core the ocean floor, extract cylinders of sediment, and read the climate record going back 65 million years through the extinction of the dinosaurs, through the opening of the Drake Passage, through the formation of the Antarctic ice sheet, through the initiation of the Northern Hemisphere ice ages. The ocean floor is a library written in calcium carbonate in the shells of single-celled organisms that nobody asked and nobody taught, but who recorded everything anyway. The Earth's magnetic field is recorded in ancient rocks. When magma cools, the magnetic minerals in the rock align with the Earth's magnetic field, like tiny compass needles, frozen in place. When the rock solidifies, the magnetic field at that moment is recorded. Scientists can read those ancient field directions from rocks around the world of different ages and trace the history of the Earth's magnetic field, where the poles were, when they reversed, how strong the field was, and in doing so, confirm the movement of tectonic plates, the position of continents in the distant past, the history of the geodynamo. The rocks are not just rocks, they are compasses pointing to a magnetic north that no longer exists, recording a field from millions of years ago. Still riadable, still giving information to anyone who knows how to ask. The Grand Canyon is 1.8 billion years of history in a single cliff face. At the bottom of the canyon, the Vishnu schist, approximately 1.8 billion years old, metamorphic rock, formed deep in an ancient mountain range, a mountain range that no longer exists, eroded to its roots, above it, layer by layer, sandstone, limestone, Charle, each layer a different environment. An ancient desert, a shallow tropical sea, a river delta, a swamp. The layers span 1.7 billion years of Earth's history, and they are all visible from the rim, looking down, each layer a chapter in a book that runs from sea level to the canyon floor. 1.7 billion years. Visible. In one view, diamonds preserved the Earth's ancient interior. Some diamonds, the oldest ones, are over 3 billion years old. They formed deep in the mantle and were brought to the surface by kimberlite eruptions, volcanic pipes that reach the mantle and carry material to the surface, including diamonds. The diamonds are not just pretty. They contain inclusions, tiny mineral grains trapped inside the diamond when it formed. Those inclusions preserve the chemistry of the mantle. At the time the diamond formed 3 billion years ago, we can analyze those inclusions and learn about the composition of the mantle, the conditions deep inside the Earth 3 billion years ago, before the first animals, before the first complex cells, when the planet was young, before almost anything we recognize as life. The diamonds are windows into a world that otherwise left no record. The extraordinary, ordinary, the things we take for granted. Rain smells. The smell of rain on dry earth. Petrichor, one of the most universally recognized and loved smells, and it has a source, two sources actually. When rain falls on dry soil, it releases geosmin, a compound produced by certain soil bacteria, actinobacteria, when their spores are disturbed. The rain landing on the soil releases the spores and the geosmin into the air. When you smell it, you are smelling bacteria living in the soil, disturbed by rain. The second component, plant oils. During dry periods, plants release oils. Those oils are absorbed by rocks and soil. The rain releases them. Combined with geosmin, the smell of rain, a love letter from the soil to the atmosphere. Snowflakes are all different, but in a limited way. The old claim, no two snowflakes are alike. This is probably true, but it needs context. Snowflakes have a hexagonal symmetry, determined by the crystal structure of ice. But within that constraint, the branching pattern determined by the specific path the flake takes through clouds with varying temperature and humidity is effectively unique. Each flake records its own journey through the atmosphere. Its shape is its biography. The temperature it traveled through, the humidity it encountered at each stage of its growth. The differences are not random. They are a record of weather written in ice. Every snowflake that falls on your upturned face, a unique autobiography of a journey through the winter sky. Sunset colors are painted by dust and smoke. The most dramatic sunsets are not on perfectly clear days. They are on days with dust in the air, or smoke from distant fires, or aerosols from volcanic eruptions. The particles scatter shorter wavelengths of light blue and violet more than longer wavelengths orange and red. As the sun approaches the horizon, sunlight travels through more atmosphere, more scattering, more of the blue removed. The remaining light is enriched in red and orange. The most spectacular sunsets after major volcanic eruptions, when the stratosphere is loaded with sulfur dioxide aerosols, are famous. The sunsets after Krakatoa in 1883 were extraordinary. Vivid crimson, visible worldwide. For years, artists painted them, described them in diaries, marveled at them, not knowing what caused them. A volcano, half a world away, painting the sky. Rainbows appear in a specific direction, always away from the sun, always at an angle of 42 degrees from the antisolar point, the point directly opposite the sun. From your perspective, you can never walk toward a rainbow. It moves as you do, always ahead, always at the same angle, because the rainbow is not an object. It is a direction, the direction in which raindrops at a 42-degree angle from the antisolar point are refracting and reflecting sunlight back toward you. The specific wavelength you see depends on the exact angle. Red at 42 degrees, violet at 40 degrees. Between them, the spectrum, a physical fact about geometry and light and water, that appears to be a magical thing, hanging in the sky, ahead of you, always moving, never reached. Soil takes 500 years to form 1 centimeter. 1 centimeter, 500 years. The topsoil, the dark, rich, living layer where agriculture happens, takes centuries to form from bare rock. Weathering, biological activity. The slow accumulation of organic matter, the building of structure, the development of fertility, 500 years per centimeter. We are losing topsoil to erosion at a rate 10 to 40 times faster than it forms. In some agricultural regions, topsoil that took thousands of years to develop has been lost in decades. The foundation of food production, the basis of civilization, eroding from fields around the world, washing into rivers, into the sea. The sky at night is full of life, not just birds, insects, billions of insects, moths, beetles, aphids, midges fly through the night air, migrating or dispersing, or simply living their lives at altitudes up to several kilometers. In the darkness, the aerial plankton, some of them carried thousands of kilometers by the wind, dispersing genes across continents. There are also bacteria, spores, plant pollen. The air at night is not empty. It is full of invisible life, traveling in the dark, above where you sleep. The future Earth, what comes next? The sun is getting brighter. Over its 10 billion year lifetime, the sun gradually brightens. It is currently about 30% brighter than when the Earth formed, and it will continue to brighten in about 1 billion years. The sun will be bright enough that Earth's oceans will begin to evaporate. The runaway greenhouse effect. The water cycle will accelerate. Water vapor in the atmosphere will absorb more heat. The temperature will climb. The oceans will evaporate. The surface will become uninhabitable. If life still exists on Earth at that point, if humanity or its successors are still here, they will need to find another home or do something extraordinary to shield the planet. 1 billion years is an incomprehensible amount of time. More time than has passed since the first animal with eyes existed, but not infinite time. The clock is running. The Andromeda Galaxy will collide with the Milky Way in approximately 4.5 billion years. Not a collision of stars. The stars are too far apart for most of them to collide, but a collision of gravity, of gas clouds, of dark matter halos. The two galaxies will distort tidal tails, triggered star formation. Over perhaps 1 billion years of interaction, they will merge into a single large elliptical galaxy. Astronomers call it Milkomeda or Milkdromeda. The night sky from Earth, if anything is alive on Earth to see it, will be dramatic. Andromeda growing, filling the sky, growing brighter. Then the chaos of the merger, then a new galaxy, a quieter elliptical, without spiral arms, without the graceful structure of the Milky Way we inhabit now. The Earth will survive the sun's red giant phase. Probably in about 5 billion years, the sun will exhaust its hydrogen fuel. It will expand enormously into a red giant, its outer layers reaching perhaps to the orbit of Mars. The Earth's fate is uncertain. Some models suggest the Earth is swallowed, consumed by the expanding sun. Others suggest the Earth survives, spiraling outward as the sun loses mass, settling into a wider orbit, but uninhabitable regardless. The oceans long gone, the atmosphere long gone, the surface sterilized. A rock in a Vida orbit around a dying star. The Earth will eventually stop being geologically active. The heat powering the geodynamo, the convection in the mantle, the volcanic activity, the tectonic plates, all of this is powered by the decay of radioactive elements, and the residual heat of formation. Both are finite. Over billions of years, the Earth's interior will cool. The geodynamo will stop. The magnetic field will weaken. The solar wind will strip the atmosphere, the way it stripped Mars's atmosphere when Mars's magnetic field died billions of years ago. The Earth has billions of years of geological activity ahead of it, but not infinite. Eventually, the engine will run down. the plates will stop. The volcanoes will go quiet. The magnetic field will fail, and the atmosphere will leak away. Slowly, over millions of years, the Earth in the far future may look like Mars. Silent, cold, geological quiet. The continents will form a supercontinent again in approximately 250 million years, called Pangaea Proxima or Amasya. Depending on which model, the details vary, but the general prediction is robust. The tectonic plates are moving. The Atlantic is widening. The Pacific is shrinking. Eventually, the Pacific will close. The Americas will collide with Asia, a new supercontinent, all the land on Earth, together, again, as it was 175 million years ago, when the dinosaurs lived on a single landmass. The geography of the Earth is not fixed. It is a slow dance, with no permanent arrangement, only temporary configurations, of which our current world is one. Wonder and gratitude, the Earth as it is. The Earth is the only known planet with plate tectonics. Venus, Mars, Mercury, the Moon, none of them have active plate tectonics, not in the way Earth does. And plate tectonics may be essential for a habitable planet. It recycles carbon, pulling CO2 from the atmosphere into rock, releasing it through volcanoes, maintaining a carbon cycle. A thermostat that has kept the Earth habitable for nearly 4 billion years. Without it, CO2 builds up as on Venus, or depletes as may have happened on Mars. The Earth is the only planet in the solar system running this particular climate stabilization system. And it may be this system unique among the rocky planets we know that allowed life to persist here for 4 billion years. The Moon stabilizes our axial tilt. The Earth's axial tilt, 23.5 degrees, gives us our seasons. Without the Moon's gravitational stabilizing influence, the tilt would wobble chaotically, between perhaps 0 and 85 degrees. On timescales of millions of years, at extreme tilts, the climate would be catastrophic. Near polar regions experiencing tropical temperatures, near equatorial regions in deep freeze. The Moon holds the Earth steady, maintaining a stable tilt, maintaining stable seasons, maintaining the predictable, reliable climate that life on Earth has evolved within. The Moon, formed from the wreckage of a catastrophic collision early in Earth's history, may be one of the reasons Earth became a cradle for complex life. We owe the seasons to a disaster. Jupiter protects us. The largest planet in the solar system, Jupiter's enormous gravity deflects many comets and asteroids that would otherwise have struck the inner solar system. Without Jupiter, the rate of large asteroid impacts on Earth would be perhaps 10,000 times higher. The bombardment would be so frequent that complex life might never have had time to develop, or would be repeatedly wiped out before it could become sophisticated. Jupiter, the distant giant, is our guardian, sweeping the solar system, protecting us without knowing we exist. Everything in the biosphere is recycled. The carbon in your body was once carbon dioxide, absorbed by a plant, built into a sugar, eaten by an animal, eaten by another animal, eventually eaten by you. Or the carbon was in a fossil fuel, buried 300 million years ago, as ancient forest, burned, released as CO2, absorbed by the ocean, or by another plant, eventually eaten by you. The nitrogen in your proteins was once atmospheric nitrogen, fixed by bacteria, incorporated into the soil, taken up by a plant, eaten by an animal, Eventually, the phosphorus in your bones was once in rock, weathered, dissolved in water, absorbed by a plant, eaten. Eventually, everything in you was something else before. Everything will be something else after. You were a temporary knot in a web of matter that has been cycling through the earth. For 4 billion years, the earth has survived everything. Formation by violent collision, the late heavy bombardment, 5 mass extinctions, snowball earth, the great dying, supervolcanic eruptions, possibly a nearby supernova, possibly a gamma ray burst. And through all of it, life has persisted. Not the same life, not the same forms, but life unbroken. A 3-7 billion year chain of living things, each generation passing existence to the next. You are part of that chain. You are the current expression of a lineage that began in the Archean Ocean that has never been broken, not once. In 3.7 billion years, every extinction, every catastrophe, every mass dying, and always survivors, always something clinging on in some sheltered place, in some deep crack, in some hydrothermal vent, in some fortunate corner, waiting for conditions to improve and beginning again. You are one of those survivors, the descendant of countless creatures that survived when others did not, closing the long breath. 100 things about the planet you are lying on that is breathing beneath you. Right now, the Earth is 4.54 billion years old. It has survived everything. It carries liquid iron in its core. It generates a magnetic field that holds the atmosphere against the sun's assault. It moves its tectonic plates. It builds mountains. It recycles them. It has been covered in ice and in shallow tropical seas and in forests so dense the sky was hidden, and in barren rock and in jungle and in savanna and in cities. And through all of it, it has kept the temperature within the narrow range where water stays liquid, where chemistry works, where life is possible. For 4 billion years, without interruption, you are lying on the most extraordinary object in the known solar system, perhaps in the known universe, a planet that has maintained the conditions for life for 4 billion years, that produced an atmosphere from volcanic gases, that filled with oxygen from the breath of bacteria, that grew forests, that developed seasons, that built coral reefs and Amazon rivers and deep oceans full of species we haven't named, that produced in one small corner, in one geological eye blink, you, and you are not separate from it, not visiting it, not residing on it. You are made of it. The iron in your blood was made in a star and delivered to Earth by asteroids. The water in your cells has been cycling through the Earth for billions of years. The nitrogen in your proteins was fixed by bacteria. The carbon in every molecule of your body was once in the atmosphere, or in the ocean, or in another living thing, or in rock. You are the Earth, in a particular temporary arrangement, wearing the shape of a person for a few decades before returning to the cycle. Let that settle. Feel the planet beneath you. Its solidity, its ancien patience, its extraordinary resilience, the thing that has survived everything, is holding you right now, as it held the first fish, the first amphibian, the first mammal, the first human, and every living thing between. The planet holds you, as it has always held everything, with no preference, with no favoritism, with the simple, physical, molecular certainty of gravity. You are on the earth, and the earth is part of you, and you are part of it. And tonight you rest, as it rests, in the slow turning of the night, in the quiet that is never quite silent, because the earth hums at 8 pulses per second, because lightning strikes somewhere 100 times per second, because the plates move a centimeter per year, because somewhere a volcano is building an island, and somewhere a seed is germinating, and somewhere a whale is singing across the Atlantic, and somewhere the aurora is dancing over a dark Arctic sea. All of it happening as you breathe, as you rest, as you let the planet hold you. One more night. Close your eyes. The earth has you. It always has.